Let me start with a story. In 1970, there was an elk named Monique. She quickly rose to celebrity when she was fitted a color radio transmitter powered with solar cells, weighing hefty 23 pounds. There were two elks actually, the Monique which wore a dummy collar for the photo you're seeing, and the real one, which accidentally caught a misfire tranquilizer dart and subsequently received that color. This first in its kind study was conducted by NASA and Smithsonian Institute with intention to track elk migrations from Wyoming to Yellowstone Park. The radio satellite, the Nimbus 3, collected not only her movements on land but also temperature, altitude, and the light intensity of the environment by reading the elk's position only twice a day, dialing a binary code. The practice of tagging animals to monitor their movements has been used for more than 100 years. As Matthew Ponsford wrote in an article at MIT Review, I quote, "Way before Monique in the 1820s, a random Africa hunter in Central Africa threw an arrow spear into a white stork. The stork survived, and with its flock, it flew back to Germany in spring, allegedly becoming the world's first tag on a wild animal. The identification of the spear's origin revealed the mystery of where storks disappeared in winter. Fast forward into the present, and we have hundreds of studies relying on animal-borne sensors, radio collars, and GPS tags of plenty sorts and sizes, which in order to be carried by animals, they need to be tranquilized. The negative effects on the health of these animals are underestimated, and studies about their long-term well-being carrying these things after the data is collected are lacking. For the sake of science, we track their planetary migrations and life rhythms for biomonitoring their health, for protection and conservation purposes, and increasingly for collecting data about the shifting global climate conditions. The seals you see in this picture, for example, allow the measurement of deep ocean currents and refine weather models which can be able to use for predicting El Niño and sea level rise. This data serves humanity without animal compliance and requires state-of-the-art computations to be analyzed. Now let me follow that story with a reflection. The amount of information humans collect today from animals is incommensurable. Simply put, we have come to this thanks to advances in technology. I would like to say because of technocapitalism. The global production chain that turns rare minerals into computing processing units long surpassed the point of no return. The data is continuously piling up onto countless heaps of invisible binary packages, greatly accessible through the free forms of distribution today. It could be an exaggeration when I say this, but bear this statement with your imagination. We are overburdening, endangering the natural resources and healthy spaces on this planet. Yet virtual, binary spaces encrypted in the cloud are always available at the expense of those natural resources, namely water, to cool these huge servers on which storage and computing servers run. The technologies that can help us make sense of the incommensurable information, gigabytes upon gigabytes, terabytes, petabytes, exabytes, uploaded and recorded every second, are out there for grabs too. This is where AI enters the Anthropocene. Artificial intelligence has come to signify the ability of machines to simulate human intelligence, but it is a broad term. As it continuously emerges in front of our screens, there is still no universal consensus of what AI really is. What we can discuss about is what it brings into the table of knowledge production. Artificial intelligence has quickly been adopted by researchers, particularly in the natural sciences, to process in record times massive amount of data from animals' life, with a special focus on what Chris Sandbrook calls conservation AI. unaccounted risks and biases slip through the streamlining and automating processes made possible by AI, reaching imperatives the likes of which social scientists and humanities scholars have not experienced before. These imperatives are there for us to engage responsibly, critically, and slowly, and reject the utility of AI whenever possible. In this regard, I follow Isabel Stengers to ponder whether a slow science with AI is possible. Impulsed by the exponential number of publications in academic research, artificial intelligence, the AI agents that populate our digital lives, cross ethical fringes. A thorough discussion about AI ethics is necessary, but overwhelms the brief scope of this presentation. Still, let's keep in mind the ethical conundrums are focused on humans and the environment. While little has been said about the impact on using data collected thanks to animals and compiled via algorithmic processes, the question arises: how can we acknowledge the agency of animals in the hybrid production of a human-animal algorithmic kind of knowledge? How do we ensure the well-being of the animals after removing sensors and trackers? Welcomed with open arms by academic elites, AI is turning into the status quo when it comes to filtering, classifying, and visualizing data. The faster, the more, the better, seems to be a statement that is propelling the knowledge industry. Data mining was a thing of the past. Now it rains from the clouds. When I say AI is turning into instead of has turned into, it's because I think there are marginalized discussions in respect to the current hype around AI in scientific research, which ought to be brought into attention. AI applications produce results based on a human initiative, a decision to train algorithms using large amounts of data, which are stripped away from their contextual meanings, culture, privacies, and sovereign origins. A prompt, a question, an image, or sound of any animal, including us, are handled and objectified as data. New values are created when this data is fed into the AI for processing. But great differences can be made. These differences reside on the responsibility and critical awareness of humans to embed the original situated meanings into the data before training the models. This entails a sensitivity for knowing what and how to ask, what and how to upload or input as data, in order to question, as we should all the time, our human actions. For example, without AI in molecular genetics, it would not be possible to create DNA and RNA maps like this via EVO2. EVO2 is a model trained with large datasets of nucleotide sequences and dependent on NVIDIA processors. And while most scientists involved look at AI as a breakthrough, using it with excitement as the assistant of choice to expand the human knowledge of life quicker, the big discussion that is neglected along the ethical, social, environmental impact sideline conceals the market revenue for companies like NVIDIA in control of developing and programming such algorithmic-driven decision-making processes. From my critical artistic position, I want to offer some suggestions to consider the employment of these algorithmic tools of AI agents in our projects, in the Abide project's methods. Number one, not everything out there is AI. We should differentiate AI agents that can interact with humans, trained with LLMs using image-text pairings and sounds that were scraped from non-consented or dubious sources from programs and tools which have been trained through supervised machine learning algorithms to detect specific patterns of information and fulfill specific tasks without being capable of autonomy. Moreover, we should think about other acronyms which AI could represent. For example, abundant intelligences, artisanal intelligences, or we could just as well question all these acronyms and intelligence at the same time. Number 2, AI is fast and easy to command. It is easy to download and play with an AI application whose veracity most likely is unverified. Understanding the transparency in AI's processes is profoundly complex. How do convolutional neural networks, LLMs, GANs, and transformers really work? GANs, I mean with generative adversarial networks. More time than simply typing a prompt is required to understand the ethical, social, and ecological implications left behind by the ongoing operation of AI assistance in everyday life. Number 3, AI for data analysis is a resource-demanding operation which many people cannot afford. There are places on the planet where technology is equivalent to inequity and injustice. There are various reasons for that, and it seems, arguably, AI is exacerbating the coloniality of knowledge. Its use is managed and developed by the geopolitical North, prominently USA and China, making AI a political product with a market value. Made possible through outsourced and offshore data network, as Tubaro et al. In this year 2025 publication, Where Does AI Come From? Established. In face of these considerations, what is AI good for in respect to our project with animals? The dilemma manifests itself: to use or not to use artificial intelligence in the Abide project. As we have learned from our first panel, there are promising open forms of designing and offering tools that foster a free circulation of co-produced knowledges with the assistance of other algorithmic forms of analysis and operations that need to be supervised, analysis and programs that are not autonomous. I am convinced this kind of what I call algorithmic detection tools can be useful for us in the project, albeit not always applicable to the many uncertain fieldwork conditions and animal encounters we will and hope to experience. In the Abide project, I have taken the lead on trying out several applications that linger on the margins of AI. That said, I have not really been working with AI agents for data analysis. I have been using, however, NotebookLM for fast reading papers, DeepL for correcting my Spanish to Portuguese translations, and Cursor AI for coding computer languages I myself cannot learn on my spare time. These three are AI agents that interact with and collect my own data. It is a compromise. It is imperative, therefore, to acknowledge these unaccountable and occult consent processes when we employ these free-to-use tools that are based on artificial intelligence models and large language models. Within the scope of our Abide project, the probabilities of factually employing AI for data analysis from animals are quite slim. One central reason for this is that we do not have yet in the project, we don't have yet collected that vast amount of images or sounds to train large models for identifying specific behaviors of endemic or local species. Or we have not come to identify their language, the animals, whether it's a corporeal language, whether it's their grunts or their animal sounds. We have not come to that point yet. For example, like it was the case of the University of Copenhagen study. Large data sets are a requirement when working with AI, especially if you want to develop a customized animal detection app, one that detects the well-being, signs, and life qualities of a specific animal species. I am sure we can deepen this discussion afterwards, but bear with me. The other reason that or impediment that we have is that so far the data we have collected with camera traps and acoustic automatic recording units, which we have already been using in the fieldwork, this data can be analyzed by simply a human looking at the screen or a human listening to the audios, meaning it can be analyzed by humans means alone. Additionally, we need to consider time and computer resources, the high level of GPU, CPU performance of multiple computers. And then there's the ethical issue of abiding to the territorial sovereignty of the people living with animals in fire-prone bioregions, like in the Brazilian case. We will not be only working in Europe, but we will be working with indigenous people in Brazil with the Xerente community. We need to pay attention and abide also to their terms and their traditions. Instead, where I see the potential is in employing algorithmic detection tools, as I already labeled them, based on machine learning to analyze images and sounds registered by the passive monitoring techniques of camera trapping and audio modes. This last one, you see the picture in the center, regards automatic recording units. Images and sounds gathered by these devices are then processed, or can be processed as we have done already, with algorithmic detection tools that can identify patterns and make predictions of which species are present. These detection programs are thus built on machine learning algorithms or deep learning algorithms, but are not autonomous. While they depend on artificial neural networks to be able to compare data and make prediction, in reality, machine learning or deep machine learning algorithms are subset processes within the hierarchy of what is broadly termed as AI. The difference of these algorithmic detection tools lies in the level of autonomy. They were programmed through specialized human supervision. They require a human overview of the computing iterations and outputs. The code is available to be inspected. In particular, the ones I show here, the 4 different tools I show here via these screenshots, were trained with verifiable scientific data, however, not entirely free of biases, therefore making the confidence of prediction of these tools for detecting species based on the analysis of sounds or images something that needs to be revised and supervised and confirmed by the human user. That means the data and the process of identification using these tools always needs to be contested and asserted with caution, something that AI doesn't really so easily allow the user to do. At the moment, this is what I have experimented with. BirdNet Analyzer for detecting bird species songs, VTO acoustic pipeline for detecting ultrasonic signals of European bats and common night insects like grasshoppers, the analysis program of QUT, Acoustic Research Group in Queensland, Australia, for measuring acoustic indexes and visualizing the acoustic energy as spectrograms. And Agouti, suggested by our researcher Nuno, for visual identification of animal species from camera traps. All these allowed me to get information from acoustic recordings, detect bats and grasshopper species of Serra da Estrela by analyzing the frequencies of songs and signals recorded with the automated recording unit AudioMoth in order to create long-duration false color spectrograms and visualize day-long soundscapes of the Portuguese study sites, which in turn enables to infer the diel activity and presence of sound-producing animals in the mountains on that site. Using the sound ecology package in R in combination with BirdNet Acoustic Pipeline QUT analysis program, I have been able to analyze sounds and visualize their spectral energy, frequency bands, times, and calculate the acoustic indices of soundscapes which Filipa, Nuno, my colleagues, and myself included, have recorded since autumn 2024. Up to date, I have only computed normalized difference soundscape index from 4 sites at Serra da Estrela, which were burned in 2022. Sameiro, Val de Amoreira, Verdelhos, and Famalicão da Serra. The normalized difference soundscape index is an index that reveals the presence of biophony against anthropophony. And in this slide you could see the chart and the visualization on the top. In other words, how much sounds are produced or vocalized by animals in relation to sounds produced by humans. Values from 0 to -1 show high anthropophony, whilst positive values towards +1, 0 + 1, demonstrate an ecology dominated by sound-producing biological entities. With these images of my ongoing analysis and fieldwork, I close my presentation, and I want to circle back to the story about Monique the elk and emphasize the different methodology in our research, which is centered on being non-intrusive compared to the seize and capture and tranquilize approach of tagging animals with sensors. Our methods are based on passive monitoring, avoiding harm and stress for animals. However, I wonder what impact am I missing by stating the value of employing passive monitoring techniques. I also wonder if some animals, beyond curiosity, are aware of these recording devices placed in their habitats and decisively themselves either avoid being photographed or recorded, or perhaps they put an act in front of the camera on purpose to please and comply to the researchers' expectations. Thank you.